Great. So welcome, Nikita, for our little conversation around the topic of aviation, which is your workshop topic here. Maybe for starters, just tell us a little about who you are, since when are you at the HBI?
Yeah, so I came here, as I like to tell a joke, I came here with COVID to Germany in 2020 from Russia. And I worked for the past probably 8 years in IT industry in different companies, going all the way up from the junior engineer all the way to team lead, and then leading different teams and building team culture, which I really enjoy doing. And I came here to study a master degree in HPI. I was personally very interested in the university because of its entrepreneurship flavor that it has. Even back then, like 3 years ago, it was only starting. And I was always looking to build this personal company. Back in Russia, I did 2 failed attempts of building a startup. We mostly died because there was not enough investments to sustain us. And then I came here and together with studying for a master degree for digital health, I was also working as a CTO in a startup that immediately hired me for some reason. And now I am out of there. I work for a bigger enterprise and I have more free time on my hands. And my passion throughout the whole life was always doing something in physical world. So I used to spend a lot of my childhood time in my grandfather's garage. Not really a garage. He had a house with a small pavilion with all the tools. And I would just tinker there for my whole childhood. And I would build a lot of planes. I was really interested in exploring how things fly. And because it's like a granddad's garage, there's not a lot of materials. You have like paper, you have some plywood, and you have to figure it out, basically. There are no accurate machines there. There are no lathes, nothing. It's just hammers and drills, and that's it. He also had a small backyard where I could test my planes as well and annoy neighbors.
So you started building planes with paper and stuff like that.
And because the normal A4 paper is very weak by itself, it's not enough for a wing. I would spend nights gluing several sheets of A4 paper together to get them more rigid, because the glue and the paper, you basically get like a paper mache kind of thing. And then you form a very rudimentary airfoil out of that. And then you strip a plank of wood to that, put a propeller on the front, some rubber bands, simple plane. It flies. So that's how I discovered how to make planes.
Like what was your age at that time?
Probably like 8 or 9.
So that was way before you started doing anything with computers, or was that in parallel? Okay.
Yeah, and my parents, that's like the best thing they did in my education, I think, that I never realized in my childhood. They tried to put me into literally every club or like activity that they could possibly put me into. I know how to spar on the sword and on the swords. Like, I don't know, that's probably a useless skill, but I know because I spent 2 years in a fighting school with swords. I know how to ride horses. I know how to sail a boat. Just because.
So they didn't ask you. It was just like, Nikita, we have a new club for you, which is now you're
learning. No, they would always
ask
me, like, are you interested in it?
Okay.
Well, cool. Even if you're not interested, just try it out. A couple of times. Oh, you're actually interested? Yeah, we'll pay you for a year. Just go. And I would do all these different things all the time. And of course, in Russia, it's not super easy to pay for that. So you always have to figure out how to get some funding for it. At least that's what my parents did. I'm not from a rich family, so it was always a struggle. So I tried to always, out of every club, to make the most out of it. So I was trying to as quickly to figure out what's the deal here, how does it work, because I knew I don't have infinite time to learn, for example, how to sail a boat.
Yeah.
So I was always this very kind of maximalist in terms of setting my goals. Like, okay, in a month I have to be a captain. There's no other way around it.
Yeah.
Same with the. At some point they noticed that I was building these planes, and they put me in a small club that was teaching school kids how to make planes, somewhere around the age of 12, a little bit later, and. I went there, and there were like two groups: super small kids in like 6 or 7 years old who don't know anything and just mostly run around and do random stuff. And then there were like I think students or like higher age group that are like way older than me, and they were doing their own custom PCBs for helicopters. And they were actually soldering them and making this aluminium chassis for the mounting. I was looking at them, I was looking at small kids, I was like, okay, I know where I want to go. It's like pretty straightforward in terms of goal setting and where I want to be in the end. So yeah, that club was very interesting because it was led by like a 60 or 70-year-old dude, like super experienced, and he always reminded me of my granddad because they're kind of in the same age group. But he would know how to basically work with any material. And I was always amazed by how he can touch like whatever is around him and make something out of it. Like he can touch this stick of wood, turn it into something, and it's a figure, or it's like a...
So you did witness that when you were in his workshops or his like,
Yeah, he was kind of teaching like that. And that's where I realized that basically whatever material you have with you, like next to you, you can make something out of it. You just have to figure out how the material works.
Yeah.
Because if you have a stick of wood, like a simple thin 1 millimeter kind of stuff, if you bend it, it breaks.
Yeah.
But if you make it a little bit moist or like put it in water for an hour, then it can actually bend, and then you heat it up and then it stays in that shape. I was like, wow, so every material has a different kind of property. And that's where I like unexpectedly went into this whole trip of material sciences, even though I never got professional education in material science. It's like 2 years of university study usually. I kind of intuitively understood that, okay, well, plastic works like that, foils work like that, aluminum foils works differently, like metals work like that. So I very quickly built up this like native sense for how materials work and how they do together and what you can do with them, which was very helpful, right? And yeah, then I went into the school and the studies, and then to university, and my kind of hobby that's always kept me energized for life was tinkering at my table. And I lived in the city, in a big city, and I never had a garage. Like at some point I couldn't travel to my granddad so much because it was an hour travel on the car and I didn't have a car, so I always had to ask my mom. So it was very, very limited amount of time that I could spend in a workshop. So I was at home, and at home you have to figure out like how you do something with the household materials. It's like I didn't have anything basically. So like, okay, well, there's a plank of wood from the balcony is not nailed to the ground. I can take that. Okay. So you really start tinkering with the scraps, and you're trying to figure out how to basically do this like janky contraptions or like whatever you can do at home. And at some point my dad noticed that, and he gave me this, like for one of the birthdays, he gave me this whole kit for your own RC car. It's like a 1-piston engine, but it's completely disassembled. You have to assemble it yourself. And I was like 15 at that point. Didn't have a clue how to assemble cars. And I spent, I don't know, probably half a year trying to figure out how to assemble it. And I still did it wrong in the end. Because
did your dad help you with that?
No,
or was it?
No. My dad always lived in Moscow.
Yeah.
And I lived in Yekaterinburg, and it's like 4,000 kilometers in between us.
Yeah.
So sometimes once per year we would usually meet in summer when I had like summer break.
So you had all these parts and you were looking it up on the internet, or did you?
Well, they have a very
yourself?
like it's like an assembly kit, so they have a very crude manual of how to assemble it. But most of the stuff you kind of either have to natively know how it works, or you have to like figure it out.
Yeah.
Which is fun, but when you don't know anything and you don't have any help around, it takes a lot of tinkering. And I was always afraid to break something because it's like it was of different materials. Again, it was carbon, it was plastic, it was titanium, and there were some like it's real components. So you have some grease, you have some springs. Like it's almost real car, just small scale.
Yeah.
Right. So when you don't know anything, you're kind of afraid of breaking stuff, and it's the one piece per of anything you have there, like one sample of.
You cannot waste anything.
Yeah,
it has to waste it, work. Yeah.
So and in the end, I assembled the clutch in the wrong way. Like I put the leaf springs the other way around. So when you would turn it on, the engine, it would just spin indefinitely and spin the wheels. It would immediately engage. And like I was, I never kind of treated people around me as I should. So I turned on my car when I finally assembled it at like 12 p.m. at night. And it's like we were living in a 10-story building. You're like surrounded with all the neighbors, right?
Yeah,
So
yeah.
when and this small engine, it screams. I didn't mount any exhaust pipes, anything like that. I just wanted to see it work. So my mom burst in the room, and I was sitting there just holding the car in my hand, not knowing what to do because the wheels are spinning because the clutch is the wrong way. I was like, Mom, turn it off. Do something. And the whole room is in smokes, right? Because the small petrol car, it doesn't use the normal petrol or diesel. They use this kind of mixture of nitro. Like it's called nitro with some oils. I forgot how the thing is called. The thing is it has high concentration of the oils to oil the motor because it doesn't have the separate oiling system. So you have to embed that into the petrol itself or like in the gas. And because of that, it smokes a lot. And because of that, you mount the whole condensation chamber, which is a part of the exhaust pipes. So it captures most of the smoke.
Yeah.
I didn't do any of that because I wanted to see it work. So my whole room was just like, it's like starting a smoke machine in the room.
Wow.
Yeah, it was crazy. But
that's crazy. Yeah,
that's how I kind of got into this more mature tinkering.
Yeah,
right?
yeah.
And then I also finally at that point somewhere internet in my hometown became stable enough so I could watch YouTube. Not in 144p, but actually in some resolution where you can see what people are doing.
Was that like a revelation to you, seeing all these videos on YouTube? Or like, did you immediately understand like, wow, this is a whole almanac of doing things, of do-it-yourself stuff? Or
not really, because back then there was no maker meta on YouTube.
Yeah.
It was like the YouTube videos back then were mostly videos about people reacting to memes. And like talking about different this reactory material that's still there on YouTube now, but back then it was the whole YouTube and some like gameplays and tutorials sometimes. Yeah, that's it. Maker Meta I think is a very recent thing. It's like started in 2015, 16, somewhere there. Before that, like it was mostly just dudes in their garage who can't really narrate or present anything. Just talking about their stuff in daily life, and it was super boring, especially when you're a 15-year-old kid. What is it? So yeah, and then as I started working as well, I finally got my first 3D printer.
Was that the time when you were already studying, or was that still in school? What time are we talking about now?
That's 10th grade probably, so still in school. I started working in the 10th grade. And it was actually quite funny because my dad at some point brought me like a MacBook Air with i5 chips, so it's like super old generation. But he brought it to me and said, "Son, you learn how to code now because it's important." I was like, "Yeah, I want to play Minecraft." And he gave me also this O'Reilly book, you know, those books with like funny front pages, right?
The birds and
yeah, and it was a book about how to build apps on iOS. And it's basically like 10 tutorials combined in one book. So you read the book and you build these different apps that they suggest by just copy pasting code from it. So actually my first mobile apps were on iOS in like emulator because I didn't have the actual iPhone. I just had to emulate everything on the MacBook. But yeah, that's how I learned how to like code in, I think it was Swift. I don't remember what was the top language back then for iOS. I think it was Swift. And yeah, then professionally I went into more or less IoT stuff. My actual first contract was from my dad working with German company because for a long time he actually lived here, and they were doing this RFID systems. They were doing smart scales for bars. So it's like a scale where you put a bottle on it and it weighs how much is remaining in the bottle.
Okay.
And it connects to your phone, so you can scan the barcode and it kind of tracks this whole inventory system. Okay. I worked there a little bit just like as an intern to try to get a hang of it, and it's all in C++. It's like a very hard language to learn. And the second project where my dad said, well, you kind of can take a lead here and like get a couple of your friends on it, maybe you do it together, was the ESP RFID system, where the idea was to have this RFID scanners.
So near field communication, they work near field scanners and microcontrollers.
Yeah. So now to do that, back then you'd need to put 4 cables down the line, right? The 2 signal ones and then power and ground. We wanted to make it either fully battery powered or just reduce it to 2 cables, only power ones, and do that at scale. So you can go to a factory and it's like 2 or 3 hectares of factory floor with different rooms that you need to cover, or a building, for example, or an office building, and you just go there and you just, on sticky tape, tap it to every door, connect the lock to it, and that's it. That's the whole connect. That was the beautiful idea behind it, to make it super easy to install and to maintain. And I got a couple of my friends working on it, and I was became a team lead because I was the only one talking to. My dad gave me kind of the contacts of the German guy who was working here in the research lab, and I was talking directly to him. He was always very pissed because we were working too slow, because we were just like school guys.
We're trying to figure it out.
Yeah. And then I was talking to the two of my friends, saying like, guys, we need to be quicker. So I was this kind of project manager.
How was that? Was it like a role? I mean, that was not what you planned to do, but
yeah, back then I didn't know what to do much, and I watched a lot of movies. So I was this kind of harsh, toxic manager. It's like, work fast.
Okay.
And in the end, I had to fix all the issues because, of course, my friends were like a step behind me because I got into this technology and how IoT works and how to code in C++ probably half a year before them. So, of course, they had a little bit less knowledge. And every time they would work too slow, I had to take over and just do everything myself, then bash them because I didn't know how to give constructive feedback. And then we would push that to production, something would fail. And it was this kind of like figuring out how to work in team very early on. But it was fun. And that's where I kind of learned this very performative way to run C++ code. Because back then, like ESP32 was not existent. There was only ESP version 1. And version 2, and at some point we got up to ESP version 12. They started releasing them very quickly. But ESP version 1 had 1 core, 1 thread, and 1 kilobyte of memory. And it's like a very, very narrow window to put your program in for like networking with other devices, because we wanted to do it like a mesh network. So you plug in the device, it automatically connects with all its neighbors, it figures out the database of RFID cards and like all this fancy stuff. And to do that in 1 kilobyte of memory is incredibly hard. That's in those situations you learn how to code very optimal code. And yeah, after that I found my first like real job in Russia, not for the lab, but for the actual company, and I became this kind of backend developer, and then I overtook frontend and then DevOps. So I kind of learned everything, like what to do in the normal IT company. And because it was a small company, they didn't really have budget or any market interest to get high quality engineers. So there was a lot of room to grow. It's like a lot of empty space around you, and you can basically learn everything. And
you could take over responsibility fast.
And managers would be completely happy with that. So that's what I did for the next 2 years. I also studied at the same time. I started university at that time. And
what did you study? Right away, systems engineering?
Or it was IT systems and communications.
Was that, I mean, you worked in that field already, but was it on purpose to go into that field? Because you could have also chosen something more, let's say, mechanical engineering, because your interest was also very hardware oriented.
At that point, I had the interest mostly in IoT stuff and this kind of right on the borderline of physical world and software world, which was for me super cool. And my dad was also always pushing for that, saying that if you really want to make money as an IT guy, you always have to be right on the border between 2 disciplines. You never work as a solely IT guy, because that's how you lose relevance on the market. But if you say, for example, you're in between construction and software, or you're in between aviation and software, and I was like, oh, aviation software, that sounds cool. Then that's where the real money is. So I never actually proved that, but I still follow that. I always try to find these boundary layers. And yeah, that was for me the interest. So I didn't want to go into hardware first. because if you get the proper IT education in Russia and here as well, you get higher salary. It's easier to find job.
Yep.
And Russian IT market, same as here, is super dry. It's incredibly hard to find engineers there, especially that have at least bachelor degree. And I knew from my previous experience that all the physical stuff I can more or less learn myself. And at that point also the YouTube Maker meta was like on the rise, and I was learning how to do a lot of stuff and how to do high quality stuff, and machine works also from YouTube most of the time. So I was like, okay, I'm covered on the physical front, I'll better go learn IT. And after the first year in bachelor's, I realized that like university doesn't really teach you anything about IT. Like I learned so much myself that university can't really give me anything anymore, apart from very theoretical, like algorithmic disciplines or mathematics that you practically would almost never use, but you can learn them just to like shape your thought process. For me, I had to validate why I'm learning this complex math, because you go through 3 years of math, which is suffering. And I had to always motivate myself to think like, why do I do this to myself? And I always thought, well, okay, actually, if you do math or physics, that kind of shapes your way of thinking in a different way. So in philosophy, you think in these high-level abstractions and you let your thought kind of fly. You don't control it. In mathematics and physics, there are more applied disciplines where you actually have to like very precisely control where your thought goes and how you think step by step. And for me, math was mostly like training this exact way of thinking. That's how I validated it. I'm also a huge fan of physics. Like for me, physics were always way more interesting. And I went into several IYPT competition. Do you know them? It's like international physics competition.
So you were competing there,
yeah.
as a participant, okay?
Because that was like the practical application of all the math and all the physics that I learned in school.
Like what did you do there? What's an example?
Oh, it's a very cool competition. I tell everyone about it because I think everyone should participate in it. So basically what you have is you usually have a list of 10 questions, some years 15, and you have a year. And questions are very open. They're kind of like research questions. For example, I worked on this artificial muscle question. The problem was like that. You have fishing line, you know, the transparent thing. And if you twist it with some mechanical stuff, or like if you just twist it by hand, it will start doing these coils at some point. And then if you stretch it a little bit and you apply heat to it, it will contract. Why? That's a task. You have to figure out why and what are the physical properties of this phenomena.
Yeah.
And I did 3 years of this competition. I started in my last year of school and then 2 years in the university. And it's kind of like a tournament. So you compete on your city level, then on your country level, then you go into international level. And the competition is very cool because half of the year you're doing whatever you need to do to figure out why. So you do a lot of research. You also do all the experiments. It's like you have to do experiments to like replicate the results in the lab as well. You measure everything, and there is no real direction of how you conduct your research. It's free. It's up to you what you want to do with it. And then when you actually go into rounds, you usually go against other schools or other universities teams that did try to solve similar problems. And then you go to the whiteboards and you say, well, in the year I did this. I think it works like that. Here's my proof. And then the other side throws a lot of counter arguments at you because most of the time their model is completely different.
Interesting.
And then the whole idea of this competition, when you actually discuss, is to come to the common conclusion in the end. And it's very time limited, so you have like 5 minutes for discussion. Or something. I don't remember the time format, but it's like very narrow in time.
And you don't know the other arguments in advance.
That for me was the most problematic thing because you spent a year preparing this stuff. You go in there, you present your stuff in 5 minutes, then they present their stuff in 5 minutes, and then 5 minutes for discussion. And you know your model and their model is completely different.
And you're deep in your model.
And you have to understand their arguments, and you can't really just say you are wrong because it's scientific discussion. Right? And that's incredibly interesting from all the different aspects, right? Because you spend the whole year designing your studies, and you also do a lot of IoT there, right? Because it's all the sensors that you have to measure everything, you have to measure it correctly. and you're doing it in a university or a school, so you don't have any money for that.
Wow.
Again, you're working from whatever you can find.
Super interesting. I can imagine. I could imagine that doing for social sciences as well, like having like social phenomenon, like around social media, and then you build your own basically theories because you tested something, and then somebody comes up with a totally different theory, and you discuss it.
Yeah, it's also a team activity. So you, when you start working on it, it's usually around 10 to 12 people working on different problems. And when you actually go into competition rounds, you settle on a team of 5 people.
Yeah.
Usually every person have like done or investigated 3 or 4 problems out of the list, so they can present them and they can also discuss them. But then when you're presenting, the whole team sitting behind you, they're like quickly writing these notes of how to like approach certain arguments, because it's 5 minutes. It's like 5 brains, and you have to think in unison at the same time. To battle the opponent and to also come to some conclusion, because the jury sits there and they want you kids just like figure it out basically. And they don't want you to go after 5 minutes saying that, okay, we stay on our model, they stay on our model, we think both sides are wrong. No, they want you to come to some agreement. And if you're a kid, especially in that age, like last year of school, first 2 years, that's like 18, 19-year-old. So you're right after your teenage rebellious year. It's very hard to negotiate or discuss anything.
That's crazy. But like, just one question, because the similarity to the car example for me is you had this car that you wanted to assemble yourself from your dad, and then now you have this theory or physical phenomenon that you study, also first yourself, and you have a year for that or half a year, and you work on it, and like, how do you even manage to stay on track there to keep going? Because I can imagine you are stuck at points, and to not say, oh, come on, I can do other stuff. Why should I keep on going there?
Yeah, that's why there are usually 12 people working on it. And that's where you kind of discover the power of the community motivation. So because usually we would do every 2 weeks, we would gather in the school after the school hours or in the university after the lecture hours. And you come together and you present. And you usually go through the same presentation over and over again, right? So over the year, you kind of build this, for the first 5 minutes of the discussion that will happen in the competition, you build this presentation of how you'll present your findings. And every 2 weeks, you just start over and say, hi, I'm Nikita. Today I want to present this problem. And you do that over and over and over and over. And then all other 11 people who sit in the room, they just throw a lot of shit at you. For every minor detail where they think you're wrong. After you're done with that, you go into discussion and think like, okay, guys, how will we make it better, because we're still a team, right? And it's like very harsh thing. I remember I was crying a lot, especially in the beginning, because it's 11 people who almost always hate you. Like you get this feeling because you're there on the stage, you barely did any research, you don't know anything about how to do it properly, and just people throwing shit at you with complete disregard to your moral, like how you feel about it.
Wow.
That kind of also prepares you to the later stages of the discussion, right? When you go into competition, you have a shell so thick against other opponents that you don't really feel their like objections. You're just, okay, that's not really scientific.
So in hindsight, you would say, even though you cried and it was very harsh, but it was worth it regarding how it prepared you for the final discussions or for your own learning.
It's kind of, it's tempering your character, right? And I think like the years of doing this very intensive discussions for this competition kind of made me a better like negotiator in general. Like now when I, for example, go into job interviews and they ask what your salary expectation, I was like, not really interested in your company anymore. Like I kind of created this whole persona for myself to not get super attached in the negotiations. And not get any emotions involved. And I think for people who never went through this harsh training, it's still possible, but it's a little bit harder. Like sometimes when I do interview some people for my company, and I mostly do tech interviews, I can ask about some problems with regarding their solution, because tech interviews I like to do this kind of collaborative problem solving, right? I give you some problem, we try to solve it together, and then I ask you, well, don't you think that this part is wrong? It's like this poisonous question, right? And I can see the panic in their eyes immediately. I was like, why are you panicking? We're just talking here. Why are you so attached, and why are you so stressed out?
Would you say that people who work for you see you as someone who gives very harsh critique then, and it's not easy sometimes for them to work for you in that field?
It definitely was like so, and it was very problematic for me when I came here to Germany and started working as CTO for a startup and started hiring people. Actually, first 3 hires that we did in tech's team, they left and said that they can't work with me because I'm too harsh. I was like, well, because they would fall into the same trap. They would get emotionally attached to their solution. And when I would say like, well, this is not really scalable, can you propose something different? They would always give a feedback and say that they feel personally attacked. I was like, I'm critiquing your solution. I'm not critiquing your personality. Sometimes I don't really care about your personality. For me, it's important that the solution is right. And I had to learn and adapt as well. So I learned that in Germany or in general in Northern Europe, people are a little bit more sensitive to that as well in general in population. Like in Russia, people most of the time in the work environment, at least with the teams that I worked with, would completely ignore that and stay on the discussion. So they would just continue working like it's normal. Here, people would be more sensitive towards feelings and emotions, and like I had to dial down the harshness. So now I always start like, don't want to critique you, but have you considered? So I learned this all like more soft phrases where people don't feel directly attacked, but I can still try to ask them around their solution. That took me a while. It actually took me like 2 years probably to adapt.
It's kind of an interesting observation from your side that you, the way you see the European or Northern European or German work culture and or like the way we give feedback compared to what you experienced before, because sometimes you would hear that from a German perspective, you would hear also that we give harsh feedback from other cultures, considering other cultures. So, for example, the Americans would say the Germans are very critique-oriented, very looking for the errors, but not really giving much appreciation.
Yeah.
But this is a different view on that.
Yeah, I don't know where this perception of German giving critique came from, because so far in all the teams that I worked with, I have to be very, very cautious about how I say stuff and how people can perceive me, because, well, that's actually what I had to learn here, is that just speaking the truth and objectively attacking someone's solution, for example, or proposal, will just turn them off from the discussion completely immediately, because they will try to defend themselves, like create this border around themselves or a shell, and just ignore all your arguments down the line of the conversation. Because they will immediately go into this self-preservation mode and just focus on themselves. So, and that, like, I never faced that in Russia. It's a little bit different here. But
maybe to jump forward a little bit to your time now at HBI, and you're doing your masters, right? And now, with all the experience that you have and all the things that you have done, you're now considering, or you're planning to do a workshop on aviation here in the Maker Universe, which is, to me, after what you just said about also like feedback and so on, and education and how you learn stuff, which is really interesting, because, like, first of all, you are very experienced when it comes to engineering these aviation models and so on. You could do stuff yourself very fast, but now you have this kind of urge or this motivation to educate other people doing that. What's behind that? What's your interest there?
Well, that's what I've been doing as like a team lead in tech companies as well. So all the time when I hire engineers, you have to first of all onboard them and like get them into the context of the company and the problem space, and that never takes a week. Like, all the managers always want to say, well, the senior engineers can be onboarded in 1 week. yes, they can like log in into their internal systems in 1 week, but usually onboarding into problem space takes longer, and then also into your practices and the culture that you build. And if the person comes from like a less efficient company, for example, and you suddenly have to teach them how to do continuous integration, delivery, and testing, and how to think in this mindset, it's a lot of coaching. And I really enjoy doing that nowadays, because I think that like being a toxic manager, I'm trying to get as much away from that persona as possible, because it's very draining. Like you lose a lot of energy trying to control everyone and being this kind of harsh boss on top. And I feel like way better way is to be this kind of coaching leader, and to teach people around yourself to be better and really invest into them, in the hope that at some point it will return to you, or they will stay around and just give you a little bit of motivation and energy to also move somewhere. Because by default, I'm a super lazy person. And for me, the greatest motivator in life is just seeing people around me in the community doing something. That's why I really like Makerspace. I come here, people always do something here. People always have ideas. And I was like, shit, I also need to do something. And the COVID years, because of that, were super hard for me. Because you just stay at home, you don't see anyone. So I watched all the YouTube I could in the 2 COVID years. And I procrastinated really hard. And that's also why I kind of want to contribute here to the Makerspace community to make it better and bigger. Because for personal benefits as well, I want to have motivated people around myself to see what they're doing, maybe join their products, share my ideas, give some feedback on them. But also was always passionate about aviation and in general flying things and how they work. I have a small fleet of quadcopters and drones at my house right now, and when you do it alone, it's just not the same. I had a pleasure of traveling to US once, and to one of my friends there, and he took me to the flying field. There were like 3 other people there, and we flew planes and quads together. It's undescribable experience when you fly together with someone in FPV goggles, so you see their plane right in front of you. And like you crash into them, they break a wing, they fall, you fall with them, you take off the glasses, you see their face, and there's nothing but joy in their eyes.
Okay, you're bonding over the crash.
Because it's planes, it's toys, like, and it's super cool. When you fly quads as well, like these quads, the FPV ones, especially the racing or acro ones, they are designed to be crushable. They're made out of carbon fiber. But they're also designed to push right to the edge of the limits of the materials that they use. So whenever you, at the speed of 120 kilometers per hour, touch a tree branch or a concrete wall, it just explodes.
With all the legal issues around it. But so that's your plan for this workshop here in the Maker Universe. You want to create little or not so little airplanes actually with everyone involved. What's your approach to how, if you have already thought about it, like how do you want to like guide the workshop participants, like what's the setting, how do you imagine this to be?
That's still to be designed, and I'm trying to run a very small kind of teaching sessions, because building a plane, a foam board plane, if you don't know anything about physical world or how to interact with it, actually involves a lot of learning. So you need to learn how to cut the foam, right, to the correct depth and like with the correct alignment. It's a lot of physical skills. And how to glue that stuff together, how the structure of the foam works. Like you have to learn the basics of how the materials work, right? And then you add electronics into it, and then you learn the layer of aviation, how the airfoil works and how the center of mass works and how to balance it and why it's important. So there's a lot of this stuff. And what I'm doing right now is I'm sometimes inviting my friends over when, for example, we got new samples of foam. I would cut something. I would like show them, you cut like this, you put the ruler like this, you cut it, and you see how deep is the cut. And I'll give it to them and see how they do it. And then I try to iterate on the way I describe stuff and like these small little details, how I describe these processes. And what I see for the workshop is just, it will be more or less collaboration where like I show one of the steps how to do, for example, how to cut foam. And then we just have several people, probably in groups, because we don't have that much space, probably working in a group of 2 or 3 people, just repeating that and trying it. And it's trial and error because it's a physical world. It's not like software. Even in software, it's trial and error, right? So you try once, it doesn't work. You try a second time, then I can come over, just help you out with it. So it's more of this collaboration. And that's why we take more time. It's not a short 2-hour workshop. It will probably take 4 to 6 hours. It depends.
Yeah.
Me alone, I can probably build this plane in 3 hours or 4 hours. But you also have to include the hours of just figuring out how it works, cutting stuff, trying it out, failing, trying it again. So it will go longer. And then we go in this step-by-step way, and we see how much we can do in a day. If we can't complete planes, we can resume next time again, or people can follow up individually, like adding stuff to them. And why we chose foam core planes, or why I kind of drove to that, is because I think out of the whole aviation, it's the most visual thing to do. It's like a huge freaking plane. It's 1 meter by 1 meter with a huge propeller in the front, right? It weighs almost 2 kilos if you fully load it. It's working with foam in general is very easy. It's probably the easiest material to work with, because it's very easy to cut, to crack, to glue. You just need hot glue for it. You don't need any like nails or any welding, nothing. And because of that, it's also super easy to fix your mistakes. Or if you crash these planes, for example, testing them out, it's very easy to patch it. And it's incredibly cheap material. Like, I don't know, we got 20 foam sheets right now. I don't know what was the money amount of cash per sheet, but I think it's like around €1 or less. And if you order in bulk, then it will be way lower than €1. So it's a great material to start with. And the other option would be to build quadcopters, which is also cool, but then each quadcopter would cost us around 500 to 600 euros, which is, for me, it's also interesting to get people involved, to see, to give them inspiration to do something themselves. Yeah. And for that, you kind of have to destroy this mental barrier of inaccessibility. Yeah. Like, why are you not flying quadcopters? Well, because I need to invest 1,000 euros in it to just start flying quadcopters. And I don't want to because I don't know what to invest into, because there are so many different directions. Why are you not flying planes? Well, I don't have one. Okay, it's like 100 euros. You can build a very scrappy, cheap plane and fly and start. So it's easier to get into, and it's easier to kind of show people how to do it and inspire them to do it themselves and to continue doing it. Yeah. And also, it's a great development platform. Like these foam core planes, once you build them, it's not a fixed model. It's like a Lego constructor. You can cut and open and glue it together and do whatever you want with it. Add systems, remove, change wings, whatever. So it's very flexible. That's why we are starting from it.
Well, it was interesting to see, like, you announced it recently in the Maker Universe Slack channel, but you already mentioned it, that you want to do this workshop beforehand here in the Maker Universe to some people. And my feeling was that they were immediately like, reaction was like, oh, really? That sounds super interesting, or I want to join. Even one of the guys said, like, I could support you in that. Considering the fact that we are an institute for digital engineering, did you imagine that there would be an interest for that like this?
No, not really. Especially like I came here 3 years ago, and I immediately wanted to investigate flying FPV quadcopters because I never had my own kind of fleet of them. So I bought a couple. I actually bought one. You can buy this kit where it has goggles, very cheap controller, and the quadcopter a couple of LiPo batteries. Yeah. So I got that to my home. I started flying. I was like, wow, that's interesting. I wonder who else is around. Yeah. I dropped a message in the Discord, in the Slack channel, on Telegram. Silence. Literally no one is interested in that. I was like, wow, Germany, or like at least my university, appears to be a dead space for like people who like aviation. That's surprising. So I kind of kept it to myself. Once I actually found like a flight club next to Potsdam. For anyone who doesn't know, there is a whole RC field 30 minutes away from Potsdam that you can go there on a bike, close to a private airport. I can drop a link in Slack channel later. But yeah, the most audience that flies there usually on Saturdays is like 50, 60-year-old fathers with their families, with their kids, that have this like huge model planes that they spend several years in building, and they fly them sometimes there. And I was like, okay, well, where are all the like 20-year-old dudes? Why is there no community around? It feels super weird. So yeah, I'm super glad that now there are people who are actually like surfacing and voicing up their interest in this topic. Because I thought there would be like 1 or 2 people max. Even if you do very, very hard marketing and just like send a bunch of spam emails, there are like 3 people at workshop. But now it seems like we can probably expect an audience around 10 people. That's why I also wanted to, when I return from vacation, somewhere at the end of March or April, I want to do this open floor meetup.
Yeah. What's this about? Yeah. What can you do there, or what's the idea?
Yeah, it's actually started very funny because one guy on the Slack said, I just bought a DJI quad. Can someone tell me about flying quads? I was like, my guy. Yeah. Let me tell you about it. And then I thought, well, maybe there are more people like that. Maybe I'm not the only one who knows how to fly quads. Maybe we can just like, get together and see how many there are of us. Like, get the sense of the community, right? To start building it. And also for me, that would be the gauge of how many people could be potentially interested in our aviation works. That's like, I like the word. I think Anna chose it for the Slack channel, but I really like it. Describes the whole like aviation direction that I'm trying to take. It's really aviation works. It's everything that's within aviation that you can do.
Yeah.
And I want to understand how many people there are right now on campus who just be interested in doing something in this direction. Not only airplanes, just quadcopters, autonomous flying, robots. So we have all these different directions we can explore. And who knows, maybe some of them will do actual good products out of that. Because it's right now, there are very few labs that are doing research in this field in the whole world. Probably like around 10 of them. In different universities. So it's a very undeveloped field compared to electric cars, for example. All right, and there's a lot of space for also new businesses, new ideas, new products here that people can go into.
I mean, the cars example is a quite good analogy to that, because or maybe you can make the case as someone who has never did anything in aviation, but who is a student for digital engineering. Why should I consider joining this workshop? What could be interesting there for me?
Well, there are 2 ways that at least I approach motivation in any project. And I think maybe some people can relate to that. That's my hope. One way is to look at the amount of potential cash and business ideas that you can get out of it, right?
Okay.
I'm a very business-oriented person. So for me, I don't go into a venture usually if I don't see any financial outcome out of it. It's like, I don't like non-profits.
And in this field, you see a lot of potential for new ventures around aviation, drones, and sensors based.
I think, well, we already see some very good examples of startups. For example, in Africa, the Zipline startup, where they have this autonomous planes delivering packages to hospitals, for example, just dropping them. And they launch them with slingshots. Super cool startup. 5 years ago, people said it would never work. Now they're the monopoly in Africa who does these deliveries, and they're growing incredibly quickly. They plan to scale. Actually, last year they wanted to scale to the American markets as well. I lost track of the news. I don't know if they did it successfully or not. But they are the only one in the whole world who does it. Maybe now they have a competitor finally after 5 years. And in this whole aviation sector, there are either companies who do professional aviation, like big planes, and they are overburdened by a ton of certifications. And that's why even if they have something creative, it takes 10, 15 years to get to the production line. And if you're a young student who are interested in making impact in the world or making some sort of business or product, you're usually not that interested into staying here for 15 years to get it down to the line. That's why this small-scale autonomous aviation is very interesting in terms of business. You can very quickly develop a product here. You can prototype. The cost of the crash or the fail is minimal compared to crashing a Boeing or something like that. And all the testing that you need to do, you can do either in space like this or right outside, go outside, just crash something. And that's why it's so interesting. So you can iterate very quickly. It's almost like building a software a little bit slower. And then the second motivation from like the pure hobby perspective, I just think that like this phenomenon of flight made by humans is just something almost magical, right? Although I know how the physics of the like airfoils work and how the pressure difference works and how the airflow works, still sometimes I look at planes or quadcopters and I'm like, this thing just magnetically hangs in the air just at one place. That's some sort of black box magic. It has this kind of feeling, and it's very interesting for me. I don't know why. It's just a cool thing to do, and again, no one really does it at a scale. Like some people do this small lab experiments, and they publish some YouTube videos of like, hey, I did this some small quad just flying above my table. I mean, yeah, it's cool, but it's like you're one guy and we have 8 billion people in the world. Why no one does it? And I think no one does it because it's incredibly hard to get into in terms of financing and knowledge base that you need to have. That's why I'm building this, to get it like open to people, to get as much people in it involved, because I want this industry to progress. To move from the dead point where it is right now. I want it to progress as quickly as, for example, rockets progressed over the last 2 years. Yeah. Thanks to like first SpaceX starting it, and now you see a lot of these smaller companies in Europe as well building returnable rockets and trying to figure out different chemical compositions for the engines and doing rapid testing. I want the same to happen to this small unmanned aviation industry. Because I think it can be revolutionary to the world. I really want to see this like cyberpunk or utopian image where like you go out on the streets and there are fleets of drones and planes just flying around, delivering stuff, doing something outside, like doing the services. And there are a lot of cool ideas, but no one is there to implement them so far.
Super interesting. I'm sure not everybody shares your vision of this future. But it's really interesting to understand your motivation behind it and like to see where you're coming from, all your different interests. And I'm super interested, and I'm looking forward to the evening session where everybody who's interested can meet to talk about this aviation idea and to talk about your desires, your wishes for the upcoming workshops, because it's all work in progress. It's a chance to bring yourself in, to bring your own ideas in and your own content. And then, hopefully have a great workshop with lots of participants. And we will definitely learn a lot by that.
Yeah. So want to see at least 20 people.
Yeah, that's
at the beginning of April. That would really give us a huge boost. Yeah, so see you all around, hopefully on campus. I'm spending a lot of time here on Makerspace, so come by, ask your questions.
House K.
Yeah. Just share your opinions and maybe give some input on where you would want to put this direction into, or like where you want to move us. And we'll try to figure it out. Right, it's how to support.
Absolutely, it's all testing right now.
Yeah.
Thanks very much, Nikita.
Thank you.
It was great. Thanks.
Yeah.